So today we're going to look at the intersecting chords theorem. So in the intersecting chords theorem, if we have two chords in a circle, so if we draw two chords in a circle, let's draw one chord cutting across the circle here, and that's the chord P to Q. And if I have another chord cutting across the circle, I'll call that R and S. Those two chords are going to meet here. Let's call that meeting point T. And what the intersecting chords theorem says, that if two chords, PQ and RS, cross at point T, then the intersecting chords theorem says that P to T times Q to T equals R to T times S to T. So each of those distances, this is the length. So the length from P to T multiplied by the length from Q to T is equal to the length from R to T times the length from S to T. And that's what the intersecting chords theorem says. Now what's particularly interesting about this one is this is also true if this crossing point is outside the circle. So if I remove this and draw this theorem again, so if this time I were to draw two chords that kind of go like that, and this is the chord P to Q, and this is the chord R to S, and this is where they meet at T, the same rule is true. The length from P to T times the length from Q to T is equal to R to T times S to T, always to that crossing point T at the end of each one. Okay, in this first example then, we're being asked to find this length X, so the D to Z length. So we've got two chords, so we've got the chord A to C and D to B, and they're intersecting at this point here, which is Z. So if we use the intersecting chords theorem, what we can say is that the length from A to Z times C to Z, so 3 times 6 must equal 5 times X. So we can say 18 equals 5X, so X must be 18 divided by 5, so X must go 5 goes into 18 3 times, it's 15 and 3/5 centimeters, or 3.6 centimeters. Okay, next example. This is where the chords are crossing outside the circle. So what we say is that if we look at the chord EF first, so if I'm looking just at this chord E to F, so we say if I start from E, the distance from E to the crossing point, so that distance would be 3G, times the distance from F to the crossing point, so that one would be 2G, must equal, and then do the same with this chord GH, so G to Y, that will be 13, times, and H to Y is 9. So 3D times 2G is 6G squared. Equals 13 times 9, 117. So then to get G squared, I'm going to do G squared equals 117 over 6. And to get G, I'm going to take the square root of that answer. You just type that into your calculator to work out how many meters that distance G is. And depending on what the question asked you, it might have just said find G, which I think this one did. So this said find the length G. It could have said find the length from E to Y, which would have just been 3 of those G's. Depending on what it asked, that's what you would give.